Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video guys, I'll be tackling the fourth question from the mid-year examination, which was written in the province of Eastern Cape in the year of 2024. Please do expect a total number of 7 videos, since the question paper had 7 questions in total. That means each and every question will have its own video, and please guys, do take this seriously. I strongly believe that knowing how to tackle exam questions will give you an edge whenever you write your mid-year exam, your preliminary exam, and most importantly, your final examination. So please do share the video to your peers so that they may have the same edge as you, and please guys, do help us grow the channel by just subscribing. Okay, consider the flow diagram showing organic reaction given below. We have 3 reactions that are there. There's reaction 1, 2, and 3. Okay, our starting point, guys, we have an alcohol over there. Let us just draw the structural formula of our alcohol so that it can make things more simpler. 1, 2, 3, 4. It's an alcohol that has 4 carbons on its parent chain, and then it has an OH ion on carbon number 2. Right, together. So the IUPAC name of this alcohol will simply be butane 2-ol. That will be the IUPAC name of this alcohol. Okay, and then for reaction 1, something happens to this alcohol. We end up having a major product as well as water together. So that means water was dehydrated from our compound together. So this type of reaction is an elimination reaction. Since there's plus water over there, that means water was taken or was eliminated in that compound over there. The type of elimination is called dehydration. Together. The type of elimination reaction is called dehydration, and the type of catalyst that we may need is H2SO4, sulfuric acid, and guys, it has to be concentrated. Together. Our sulfuric acid has to be concentrated. Whenever guys we eliminate water in this compound, we are going to use Zaitsev's elimination rule for us to determine the product. Together. Yes, I know that guys, OH will be eliminated, but I don't know which hydrogen will be eliminated between this one or that one. According guys to the Zaitsev's elimination rule, I must eliminate the hydrogen from the carbon with the least number of hydrogen atoms. If I can check here, I have two hydrogens there, and I have 3 hydrogens there. So that means I must eliminate on this carbon over there together. So the major products that will be formed will be an alkene that has a double bond between carbon number 2 and 3. That will be our major product together. So the structural formula of our major product, we will simply have an alkene like this. Let's have H and H over there. This is the structural formula, guys, of our major products. And obviously the IUPAC name is but2in. The IUPAC name is just but2in. Okay, so now let's go to reaction 2. Reaction 2, now guys, we can see that there's something which was added, which was a halogen there. Okay. So I can see that the number of hydrogens also increased as well by 1, because I had 8 hydrogens, but now I have 9 hydrogens. So for reaction 2, guys, the type of reaction that takes place there is an addition reaction, guys. And this type of addition is called hydrohalogenation. It's hydrohalogenation because I've added 1 hydrogen as well as a halogen over there. So this type of a reaction is called a hydrohalogenation, and it's an addition reaction. This compound over there will be called alkane. obviously, guys, whenever we do our addition reaction, we are going to apply Markov-Coase rule. Né? It simply says the hydrogen will go to the carbon that has the most number of hydrogen atoms. Né? So if we check there, guys, both carbon number 2 and carbon number 3 only have one hydrogen atom. So you can either have your bromine here or your bromine can be there. It wouldn't make any difference, because the IUPAC name will simply be the same. Né? So the IUPAC name of our compound formed in reaction 2, we simply have 2-bromobutane. Okay, and then for reaction 3, guys, we are substituting. Né? We are moving from an alcohol into a haloalkane. For us, guys, to be able to substitute over there, this alcohol is taken, it will be substituted. You can see that it's in carbon number 2, as well as our bromine is in carbon number 2, right? So we'll just substitute these two, and for us to substitute these two, guys, we will need, okay, the type of reaction is substitution number 1, substitution, and then the reaction conditions that are needed. We will need a strong base. It can be lithium hydroxide, potassium hydroxide, or sodium hydroxide. Né? Please note that, guys, since you are dealing with substitution reaction, the base must be dilute. Are you together? The base must be dilute. Né? And we will also need mild heat over there as reaction conditions. Né? Okay, now let's answer the questions, guys. First question, we are focusing on reaction 1. Okay, they want us to write down the name of the elimination reaction. They're already telling us that for reaction 1, guys, it's an elimination reaction. Are you together? And the type of an elimination reaction will be dehydration, since we are eliminating water. This is just dehydration. Okay, and then the name of the inorganic reagent needed is sulfuric acid. They want the name of formula. Né? It's H2SO4, and guys, please remember, it has to be concentrated. It has to be concentrated. Né? You'll simply need a concentrated sulfuric acid. Now they want us to balance to write down the balanced equation using structural formula for the organic compounds. Okay, we simply had our alcohol there, and the OH ion was in carbon number 2, and then we had our hydrogens. Are you together? We are eliminating over here, so we'll end up forming a major product and an inorganic compound. Né? And we said that our major product will simply look like this. Will simply look like this. H, 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 and H there. Né? Okay, please note that, guys, according to the Zaitsev's elimination rule, we will always take the hydrogen from the carbon with the least number of hydrogens. Are you together? So that's why we are taking that hydrogen over there. Né? And then obviously the inorganic compound that we form will be water. Now let's go to reaction 2. We are told to write down the name of the type of reaction that takes place. For reaction 2, guys, it's an addition reaction. Né? We are moving from an unsaturated hydrocarbon to a saturated haloalkane. Are you together? So that means we have undergone an addition reaction. Since we have added both the hydrogen and the halogen, the type of addition reaction will be called a hydrohalogenation. Né? The type of addition is just hydrohalogenation. So it's just addition. In brackets, you can simply write hydrohalogenation. Okay, now they want us to write down the structural formula and the IUPAC name of our major product. Okay, we did draw our major products already, guys. Now we said that you are adding hydrogen bromide over here, né, for us to form that compound. We are taking this alkane plus hydrogen bromide to form our halogen over there, né? So the structural formula, guys, you can simply draw it like this: 1 2 3 4 1 2 3 1 1 1 1 1 1. You have your hydrogens over there. And then, guys, you can draw your BR over here or BR over there. It's fine, guys. Ne? The IUPAC name will still be the same. It's one and the same compound. This thing is called 2-bromobutane. This is called 2-bromobutane. Ne? Okay. For reaction 3 is a substitution reaction. We are moving from an alcohol into a haloalkane. Are you together? They want us to write down two conditions that are needed. You need a dilute strong base. A dilute strong base. Are you together? And that base can be lithium hydroxide. It can be potassium hydroxide. It can be sodium hydroxide as well. Ne? But please note that, guys, your base, your strong base has to be dilute. The other condition you just need mild heat. You just need mild heat. Ne? Okay. And then now you're told that octane can be cracked according to the following incomplete equation. Okay. The incomplete equation. Okay, we are told that the two straight chain organic compounds C4Hy and C4Hz are now passed through bromine water at room temperature in a dark room. The following observations are made. Okay. The reason why, guys, they are reacting these two compounds in a dark room, because we want to determine which compound between the two is saturated, which one is not is unsaturated, ne? And the one which is saturated, guys, will never react with bromine water in a dark room. But the one that is unsaturated will react with bromine water in a dark room, ne? Why? Because the one that is unsaturated, it has double bonds, so it has the weakest intermolecular forces compared to the other one. That's why it will react easily with bromine water. Okay. For experiment 1, guys, they are taking C4Hy. They are reacting it with bromine water and they see no change. That means C4Hy, guys, is a saturated hydrocarbon. The only saturated hydrocarbon that you can form, it can be C4H10. Are you together? That will be a butane, né? And then over here, guys, the only unsaturated hydrocarbon you can form, it will be C4H8. If you can check, guys, yes, this makes sense because you are cracking C8H18, you'll end up forming C4H10 plus C4H8. The number of carbons must be balanced on the left hand side, so is the number of hydrogens, né? So everything is balanced over there. It's C4H10 and C4H8. Are you together? Okay, now let's answer this question. They want us to define a cracking. Ne? Cracking, guys, is just a breaking down of long chain hydrocarbons into small useful hydrocarbons. Ne? We are breaking down long chain into smaller useful hydrocarbons. And then 4.2.2, we are supposed to give a reason why experiment 1 and 2 is carried out in a dark room. Because if, guys, experiment 1 and 2 are not carried in a dark room, we wouldn't be able to see which one of the two compounds is saturated or not, né? Because for the saturated compound, it will undergo substitution, and yes, this will just undergo addition reaction. Are you together? So for us to eliminate having substitution reaction, we must not expose these two experiments. They must not be exposed through UV lighting. Okay, which compound C4HY or C4HZ is unsaturated? We have already established that, guys. C4HZ is unsaturated. Are you together? C4HZ is an alkene. Please remember that. And then we are told that compound Y undergoes the following reaction. Compound Y, they are adding not compound Y rather, but C4HY. Remember that, guys. C4HY is basically C4H10. It's butane. They are reacting butane with chlorine water in the presence of UV light. Are you together? So what will happen here, guys? We'll simply have a substitution reaction that will result in a primary haloalkane and hydrogen chloride. Are you together? So we'll end up having a primary haloalkane. So the structure of our primary haloalkane will simply look like this. 1, 2, 3, 4. We'll have our chlorine at the terminal carbon, since we have a primary haloalkane. So that will be our structural formula, guys, of our primary haloalkane. Okay, and then now they're taking the primary haloalkane, they're reacting it with a concentrated sodium hydroxide. Obviously, guys, if you take a haloalkane, reacting it with a concentrated sodium hydroxide, we are eliminating. We'll end up forming compound Z, which is an alkene. Are you together? And then we'll have two inorganic products, that is sodium hydroxide as well as water. Are you together? Okay, so I now know that, okay, since I can use my butane to form this unsaturated hydrocarbon, that simply means I can draw the structure of the unsaturated hydrocarbon. Its structure will just look like this. C4 I'll have my hydrogens over there. Please remember that, guys, this type of reaction is an elimination reaction. For elimination reaction, we are going to use our Zaitsev's elimination rule. So we'll just eliminate the hydrogen there and the chlorine there. Are you together? And then we'll end up having that double bond. So this is the other compound, which is just C4H8, but initially it was CZ. C4HZ. So the IUPAC name is just but1-in. Okay, so now let's answer the following questions. They want us to write down the structural formula of C4HZ. C4HZ, guys, is our unsaturated hydrocarbon. It looks like this. It looks like this. It looks like this. I just have to draw my hydrogens over there. That's how guys it's supposed to look like. And then now they want us to write down the combustion reaction of compound C4HY. Remember that, guys, C4HY is butane, so that's C4H10. For combustion, I'm supposed to react this thing with oxygen, and I must form carbon dioxide and water. Are you together, guys? And then all I have to do now is to just balance these two sides. On the left hand side, I have 4 carbons. That means on the right hand side, I must also have 4 carbons as well. Né? On the left hand side, I have 10 hydrogens, but on the right hand side, I have 2. That means I just need to write 5 over there. Né? And then how many carbons do I have on my left hand side? I have 4 times 2, which is 8, plus 5, that's 13. The coefficient over here, guys, is always the half of the number of oxygens that I have on my right hand side. Are we together? So since I have 13, half of 13, guys, is basically 13 over 2. But it's kind of weird to leave our stoichiometric coefficients as fractions. So for us to remove this fraction, we just need to multiply each and every stoichiometric coefficient by our LCD. Our LCD is just 2, right? So we'll end up having 2 C4 H10 plus 13 O2 plus 8 CO2 plus 10 H2O. If you can check, guys, we have 8 carbons and 8 carbons. How many hydrogens? 2 times 10, that's 20. We also have 20 hydrogens. The number of oxygens, it's 13 times 2, that's 26. I have 8 times 2, that's 16, plus 10, that's 26. So everything is balanced, guys. Né? So that's how, guys, we're supposed to tackle that question and get your full marks. Just stay tuned, guys, and wait for more videos. Thank you for your time.